hot, vibrant, loud. The fire tornado is all three, and much, much.
Smart! Our fluids project is a fire tornado. We want to know how many marshmallows we can toss at once using it. In other words, what is the relationship between the spinning speed and the height of our flame?
One way of answering the question is to use control volume analysis and Buckingham pi theorem. We can imagine the control volume as a cylinder, where mass flows in through the curved surface and out through the top circle. A simple way of causing this mass flow is to offset two halves of a cylinder as shown to create a vortex in the column. We chose instead to use 6 spinning blades that draw in air to control the velocity. Writing a conservation of mass equation gives us the exit velocity through the circle as a function of spin speed, assuming air doesn't get trapped in the control volume. We can use Froude's number to describe the relationship between exit velocity and the height of our flame. Writing the pi term as follows allows us to calculate a linear constant from collected data. Another relationship we found from the same research paper was this proportionality. It relates the height of our flame, the diameter of the cup of our flame, as well as the circulation in our cylinder. Circulation is found by taking this pattern, which is evaluated using our angular velocity and radius. This expression, this proportionality, tells us that the height of our flame increases when we increase the circulation, but it's limited by our cup's diameter. Now on to building this thing and seeing how it works in real life.
From this video, we gathered the angular velocity and corresponding height values in Tracker, which we then imported into this spreadsheet. As you can see, there are 8 clips in which angular speed increases between each clip. We processed all of our data in MATLAB, and this first graph shows that as angular speed increases, flame height also increases. This data can be linearized to solve for Froude's number as shown in the second graph. The slope of this line is 2.3582, which is Froude's number for our fire tornado setup.
As you have seen, combining conservation of mass with Froude's number tells us that the square root of our flame height is linearly related to the angular velocity, which, in turn, is proportional to circulation.
This is confirmed by a research paper with the caveat that the maximum flame height is limited by the diameter of the flame's cup. This relationship holds for all small fires that aren't affected as much by burning rate and buoyancy.
Circulation is the mechanism that draws more air into the control volume, so the stronger the circulation, the higher the flame. We now have an approximate function for marshmallows burned per angular speed. Remember kids, don't play with fire if you're not up for
Smart!